Joining me now is Matt Kelly. He's the Chief Technology Officer for IPC. Welcome, Matt. Nice to see you.
Hi, Trevor. Nice to see you.
Okay. So some exciting news. You've apparently got a new job recently. A couple of weeks ago, you were made responsible not just for the technology side of IPC, but also moving the standards and guidelines ahead. So tell us about it.
Yeah, no, it is a new announcement. I think we're just a couple weeks into the job here, so still kind of sorting through kind of some of the background of what we're looking to do here. But the exciting thing about it is that pairing technology solutions, which is the group I've been running for the last couple of years, which is more of a forward-looking seeking of new needs for technology, guidelines and standards, training, advocacy, awareness of these things. When we've talked about that over the last couple of years ourselves here, but now pairing that with our core of IPC standards development, and so these two groups now are reporting to me, and so the way that we're looking at this is kind of on the technology solutions side, seeking what the industry needs and wants for these new either guidelines or standards, and that's either coming kind of from our increased activity in the packaging world, but also what that really means to kind of the back end of assembly and PCBs and PCBA assembly. But then also on the standard side of things, we've got obviously 65 years of standards development expertise and background, and just really trying to align that with some of the newer technologies, but then making sure that we can look at new ways of delivering standards, right? AI is all around us. Do we have to look at new ways of how we deliver our standards from IPC? Yep. And kind of the usage of standards, how people are really using them. So I look at the combination of both of those groups being really kind of enabling us over the next few years to not just look at the new content that we're developing, but how we develop and how we deliver that, right?
Yeah.
So I think it's good.
Yeah, with all the automation that's coming into the industry, with AI, with robotics and automation as well. I mean, I guess these systems are being set up in some cases to IPC standards. So the way that you deliver the data and information to the people who are writing these programs and doing that kind of thing, I guess is quite important.
It is, and so obviously everyone talks about AI, and there's obviously risks and opportunities there, but not just the use of AI in terms of delivery, but also speed. Yeah. We talk a lot about how fast technology is changing, and the challenge with a standards development organization like IPC is how can we be as close to that leading edge as possible. We're never going to be on top of it. There's obviously intellectual property and things that are protected in the companies, but if we can kind of push closer to that and be very proactive, then we will hopefully see kind of more variety of standards that are needed from quality, reliability, performance aspects and things that the industry really needs to run, but also to make sure that we're delivering that in a timely manner. Yep. So I'll give you an example, and I'm not quoting real numbers here, but if you look at kind of existing timeframes for development, you can look at somewhere between 2 and 3 years of kind of effort to get into standards. Yep. Now when you kind of match that up to the rate and pace of technology, that may or may not work, right? So can we get into an area where we can develop a guideline in 6 months, in 9 months? Again, I'm not saying that's necessarily the case here, but those are the kind of the driving forces that we're working towards, so that we can kind of deliver that content to the industry as needed.
It'd be wonderful if you could do that. I mean, of course, one of the issues is that standards are usually, it's driven by membership who are volunteers. Everybody's got different schedules, and getting everybody to coordinate together takes quite often takes time. But I think it's a much more natural funnel to be driving it from the technology side down into the standards.
Yeah, and certainly, so I can say definitely for sure that we are, we're examining these new technologies like the use of AI, and looking at our process development processes and things to see, where those opportunities are, so that we can actually, get to, faster time to market. So that definitely is occurring.
Okay. So if we look over the last 12 months, I mean, what would you say have been the biggest challenges that you've had technically?
Well, certainly the last 2 or 3 years have been really occupied with a lot of new packaging technologies, from the U.S. CHIPS Act, for example, the European CHIPS Act, and again, we've talked about that in previous interviews. I think that the biggest challenge now over these last 12 months now are really trying to acknowledge the variety of those changes. So, this is a period of time where we're actually looking at the largest types of components that we've ever seen, driven by AI, HPC computing. We're talking, 100 millimeter, 120 millimeter, 150 millimeter packages. 20, 40, 50 pieces of silicon, stacked HBM memory. I mean, I could go on and on. So these are very large devices, very expensive devices.
And they also run very hot.
Run very hot and, challenging to put down. So all of these things. And at the exact same time, we're actually dealing with the smallest type of electronic components that we've ever seen in our watches, in our phones, due to all the the multi-functions that we want in these devices, right? So it's a very interesting period of time where we've got challenges on the largest componentry and the smallest componentry, so that we can have phones and watches do the cool things that they do today, right? So in terms of the technical challenge over these last 12 months is, as this has been unfolding at the front end for silicon, semiconductor, and packaging, really trying to raise the awareness of the back end of the value chain into printed circuit boards, HDI, as well as PCBA and EMS manufacturing. Because make no mistake, these devices, whether they're really big or really small, are going to be drastically impacting printed circuit board design, HDI design, printed circuit board assembly.
Right.
And so if we kind of look back, back in the, I'd say, mid to late 90s, if we kind of throw it over the wall with, these new technologies and hope that, these can be built reliably, I think we're going to be dealing with some pretty big problems. So what we're really trying to do is bridge the new technology changes that are coming from the front end to the back end, so that we can understand, not only are these things really great working at the component level, but they can actually be made with high quality, high reliability within a system. So we're taking a systems view of this, Trevor.
Right. So I mean, it sounds almost like, as I said, you're looking at the heterogeneous integration that's going to the back end packaging, and expanding that out to the board level, really, so that you're getting compatibility with materials and things like that. So you're going to get optimum reliability and quality.
Yeah, I mean, it's been an exciting time, because we've really had to look at ourselves and say, what is IPC's background? What is our value delivery to the industry? And we are not really coming to the industry from the component level. We've had component level integration all along here, but that's not necessarily been our strength. Our strength has been coming from the system level at printed circuit board assembly, right? So the idea is that we, as an organization, are coming in from the from the right to the left, in terms of saying these are the things that are really important at a system level while you're developing and dreaming up these new types of components. Let's not forget about quality, reliability, assembly, yield, all of these things to make the final system. Because as cool and awesome as these new packages are on glass substrates with lots of silicon and all these wonderful things that we're doing in the package level, if we don't integrate those into a system, we don't have a system.
Right.
So that's basically our value add, is we're coming at it kind of more from the system side into things, and making sure that we're looking at the various aspects, particularly reliability.
Right. Yeah, I mean, a lot of these big data centers that we're putting together for, for AI, etc. they're running very hot, and that they're employing new technologies where they're using cooling systems, using liquid cooling for electronics, which sounds a bit of an anathema, but that's what they're doing. What's your view on that? And are you looking to do any standards around that, or is that something that's just industry driven at the moment?
No, absolutely. I mean, thermal management and challenges of these final systems is probably one of the largest problems right now we're facing, kind of from an engineering perspective. So yeah, I mean that's top of the list in terms of guidelines and standards developments, whether it be kind of more of the mechanical aspects of getting these heat exchange type of systems into a package area that's very very small or very, very large, but also in terms of the actual design up front and simulation, getting into like digital twin and those types of things, so you can model this stuff before you actually have to go create these systems, because they're very complex. They cost a lot of money to make, and you want to understand the performance before you start to get into it. So yeah, we're looking at that and kind of merging not just the physical design of these things, but also utilizing some of the digital techniques that we established through digital twin, CfX, that sort of thing. Yeah,
so that was going to be my next question, was really to say that what is the progress with CfX? I mean, it's been going a couple of years now. Has there been greater adoption of the qualified vendors list, and where are you taking that technology or that standard? How are you developing it?
Yeah, so I'll answer a few different ways. So I think we're in I believe it's like the 8th year now that CfX has been alive, in a standards format. But obviously it's being practiced in manufacturing as well as a real life process. So the adoption rate, I think it's slower than what I would like to see, but these things do take time. There's a lot of benefits. I think we've talked about the security and the architecture in general was written to be very agnostic in the sense that you can apply it to different processes, which is, I think, a kind of an interesting growth area that I can kind of talk about here in a second. But the adoption rate in the EMS industry, I would say, is a little bit slower than I'd like to see. It is dependent on geography. So we're seeing some really nice uptake in Asia in particular. A lot of manufacturing is going on there, a little bit more than what we're seeing in North America. So we've seen some really nice adoption, particularly in Taiwan. There's groups like TIMA and others that are really embracing the technology. So I think the time is there. People are starting to realize the value, the benefit, the security of the system. Right. So yeah, it's increasing in adoption. The QPL list, in terms of equipment vendors that are offering it, it's growing as well. Again, it was all written around originally the EMS factory, which is good. The exciting part that I see now, kind of thinking about the next couple of years, is as it's been written kind of from an architectural standpoint, we can actually see interest in more at the front end. So we're seeing this in terms of interest in terms of IDMs and OSATs for packaging. Okay. And we've actually even seen some interest on the semiconductor side. And we know that the data usage of those companies is much higher than the back end. So hopeful that there'll be some interest there. And then the last thing I'll say is that we're seeing some more coupling and interest with CfX with the usage of digital twin. Right. So we'll see how that plays out. But these things always take a little longer than what we think. Right. But it works, and it's secure is a really important element. I think that's the attraction, isn't it? I mean, the security of CfX, I mean, it was built around the same sort of protocols as banking software. Yeah. So it's very, very secure. Yeah. So, talking about how you then develop that through or introduce a digital pipeline into digital twin, how do you envisage that happening? You envisage the data that's coming out of the CfX essentially going forward to create some sort of representation of a process in digital twin form? Yeah, and so we've been working a little bit, say with NIST, for example. We've had there's been several meetings over the last few years. The USA Manufacturing Institute was just stood up under SRC, and the need for digital twin continues to go up as our hardware costs go up and up and up, right? So the way that we describe that is we take digital twin concepts and combine that with CFX. So digital twin is a kind of a digital shadow of a physical process, right? So you can mirror it, you can mimic it, you can do what if scenarios all around, what that process, big or small, might occur. So there's value in that. You can understand very clearly what's going to happen without even building anything in the physical form. Right. So in order to do that, you need data. Yeah. And so what a lot of people kind of forget about is they get so excited about what could happen in that digital twin, but they forget about how the data got into the digital twin in the first place. And that's where CFX come into play. So CFX can be that pipeline, or is that pipeline of data that can feed the digital twin. And so this was, again, back to the original pioneering days of folks like Michael Ford and those original teams that were coming up with this type of concept, is that in order for you to have a good digital twin, real-time data, all the detail in the metadata, all those types of things, you need a really good pipeline to get that data in. So CFX plus digital twin now actually can help you with a working model, and that's why we've had both digital twin and CFX standards in play for quite some time now.
Yeah, excellent, excellent. Well, it sounds like you're doing a lot of exciting things, Matt, and it's developing in the right direction. Again, as you say, speed is obviously one of the challenges you'll have, trying to keep up with everything that's happening. But it's always good to catch up and to be able to hear what's happening in the technical level at IPC.
Thanks for having me, Trevor. Appreciate it.
Thank you. Okay.